Rational Raphael here, talking to you about solving rational equations. Now here's a question. What do you call it when a turtle takes a picture of himself? A selfie!
First thing we're talking about is an excluded value or excluded values. Those would be any values that when plugged in cause the denominator to equal 0. So when we're dealing with rational expressions, those would be fractions where the numerator and denominator are both polynomials. Any value of your variable that would cause the denominator to equal 0 is going to be classified as an excluded value because you can't have your denominator equal 0, otherwise your rational expression will be undefined. If you're not sure how to find your excluded values, just take your denominator, set it equal to 0, and solve for your specified variable. Next vocabulary term is a rational equation. That would be an equation containing at least one fraction whose numerator and denominator are polynomials. So down here you can see 4 examples of rational equations, and this is what we're going to teach you how to solve today. Now let's talk about how we go about solving rational equations. So to solve a rational equation, the first step, just like when we are multiplying and dividing rational expressions or adding and subtracting rational expressions, we need to completely factor the numerator and denominator of each fraction. So when we're talking about completely factoring the numerator and denominator of each fraction in a rational equation, we're talking about if there's a binomial. Is there a number or a variable you could take out of each term? If there's a quadratic trinomial, is there a way you could use a magic X to factor it? Here we have monomials in our numerator and denominator, so we're good. These numerators and denominators are as factored as they get. So we can move on to step 2, where we state any excluded values. Those would be values of your variable, in this case y, that would cause any of these denominators to equal 0. If you're not sure how to get that, you just set each denominator equal to 0 and solve for y. Here, if I set 2y equal to 0, solve for y, divide both sides by 2, I get y is equal to 0. That's one of our excluded values. Here, if I set 10 equals 0, oh, there's no variable here, so we're good there. And then if I set 5y equal to 0, solve for y, I end up getting y is equal to 0 again. So our only excluded value would be y is equal to 0. That would cause both of these denominators to equal 0. Therefore, it's an excluded value. So we have to write y cannot equal 0. Now we can move on to step 3, where we make sure each fraction has a common denominator. So we look at the denominator of each of these fractions, and we need to determine what is the least common denominator between 2y, 10, and 5y. Well, I think it's going to end up being 10y. So how would I get this denominator to be 10y? That would be 5. And remember, whatever I do to the denominator, I have to do to the numerator. That way I'm multiplying by a form of 1, it doesn't actually change my fraction. Next, what do I have to multiply 10 by in order to get it to be 10y? That would be y. And whatever I do to the denominator, I have to do to the numerator. Lastly, what do I have to multiply 5y by in order to get it to be 10y? That would be 2. And whatever I do to the denominator, I have to do to the numerator. Now let's multiply these out. 1 times 5 is going to give you 5 in our numerator, and then 2y times 5 is going to give you 10y. Then plus, and over here, 3 times y is going to give you 3y in our numerator, and then 10y in our denominator. And then lastly, 1 times 2 is going to give you 2 in our numerator over here, and then 5y times 2 is 10y. Now you see, each denominator is exactly the same. We have a common denominator with each fraction. So we can move on to step 4, where we multiply both sides by the common denominator to cancel it out. So the cool thing about getting each fraction to have a common denominator is now I can multiply both sides of this equation by our common denominator, and all of the denominators will cancel out. Over here, I distribute the 10y to the 5 over 10y and to the 3y over 10y. And when I do that, this cancels out with this and this, so we end up just being left with 5 plus 3y on this side of the equation, and over here, this 10y cancels out with this 10y, and we're left with 2 on this side of the equation. Now that all of the denominators are gone, we can move to our final step, which is to solve the equation that remains. So we have a basic equation here that we can solve for y. So we get our variables to the left, done, constants need to go to the right. We start with anything added or subtracted to our variable, so this 5, we're going to subtract to the other side. These cancel out, and we're left with 3y is equal to negative 3. We then divide both sides by 3 to get y all by itself, and we get y is equal to negative 1. Always at the end, check to make sure your answer is not included in your excluded values.
Why is turtle wax so expensive? Because their ears are so small. That's not really good. Example time.
Now example 1, to solve the given rational equation. So here's our rational equation. We just need to follow our steps. What is step 1? It's to completely factor the numerator and denominator of each fraction. Here, our numerators and denominators are monomials, so we're good. They are completely factored. We can move to step 2 then, which is to state any excluded values. So those would be values of our variable that cause any of these denominators to equal 0. To figure out what those are, we just set each denominator equal to 0, solve for x. Here, there is no x, so we're good. Here, we set 2x equal to 0, solve for x, we get x is equal equal to 0. Therefore, x equals 0 is one of our excluded values. Over here, we set 3x equal to 0, solve for x. We again get x is equal to 0, so our only excluded value here would be x cannot equal 0. That would cause these two denominators to equal 0 and be undefined. So we can move on to step 3, where we make sure each fraction has a common denominator. And again, this is probably going to be the hardest part of solving a rational equation, is determining what is the least common denominator here between 12, 2x, and 3x. Well, I could get each of these to be 12x. Can I get this to be 12x? Yes. So that's going to be my least common denominator, 12x. So how do I get this to be 12x? Well, I just multiply by x. And whatever I do to the denominator, I have to do to the numerator. Then I subtract, and I have 1 over 2x. How do I get 2x to be 12x? Well, I have to multiply it by 6. And whatever I do to the denominator, I have to do to the numerator. And then over here, what do I have to multiply 3x by to get it to be 12x? Well, that would be 4. And whatever I do to the denominator, I have to do to the numerator. Now all I have to do is just multiply. 5 times x is going to be 5x in our numerator, and it's going to be over our common denominator 12x. Minus, and then it's going to be 1 times 6 in our numerator here over our common denominator 12x, and that equals, and then 1 times 4 in our numerator over here over our common denominator 12x. Now each fraction has the exact same denominator. We have a common denominator. So we can move on to step 4, where we multiply both sides of this equation by our common denominator 12x. The reason is because when I distribute this 12x to each of these fractions, it's actually going to cancel out with each of these denominators, leaving us just with 5x minus 6. On this side, the 12x here cancels out with this 12x in our denominator, and we're just left with 4. Now we have this basic equation that we could solve for x. So we move to step 5, our last step, which is to solve the equation that remains. So how do I solve this? Well, I get my variables to the left, constants need to go to the right. Start with anything added or subtracted to our variable, so this negative 6 has to go. I add 6 to both sides, then I have 5x is equal to 10. I then divide both sides by 5 to get x all by itself, and I get x is equal to 2. Always at the end, check to make sure that your answer is not included in your excluded values.
I'm too tall, and this suit doesn't even fit. You try.
Okay, doing the same thing. Step 1, we need to completely factor the numerator and denominator of each fraction. Since we're dealing with monomials, we're good to go. We can move on to step 2, where we state any excluded values. Those would be values of p in this case that would cause either of these denominators to equal 0. To figure out what those excluded values are, we just set each denominator equal to 0, solve for p. We just get p is equal to 0 for both of these. So our only excluded value would be p cannot equal 0. Now we can move on to step 3, where we make sure each fraction has a common denominator. Again, this is the hardest part of these questions, is to figure out what is our least common denominator. So these two fractions already have a common denominator. It's p. So is there any way that I could get p to be our least common denominator? Well, I would need this denominator over here to be p. Well, if 5 is the same as 5 over 1, what would I have to multiply 1 by to get it to be p? That'd be p. And whatever I do to the denominator, I have to do to the numerator. So if I multiply this fraction by p over p, that should give us a common denominator of p with all of these fractions. So when I multiply these two together, 5 times p just gives us 5p in our numerator. 1 times p is p in the denominator. So yes, now all of the fractions have a common denominator of p. Once we have that, we can then move to step 4, where we multiply both sides of the equation by our common denominator, which in this case is p. So when I do that, I distribute the p to this fraction and to this fraction. And when I do that, it cancels out each of the denominators. On this side, when I multiply this fraction by p, these p's cancel each other out, just leaving us with 17. Now I have this basic equation that I can solve for our given variable p. How do I do that? Well, I solve like normal. I get my variables to the left, constants need to go to the right. We start with anything added or subtracted to our variable. So this plus 2, how do I move that? I subtract 2 from both sides. That way these cancel each other out, leaving us with 5p is equal to 15. I then get p all by itself by dividing both sides by 5. These cancel out, and we get p is equal to 3. Always at the end, check to make sure your answer is not included in your excluded values. Example 2, doing the exact same thing. So we have a rational equation. How do we solve this? Well, we need to first completely factor the numerator and denominator of each fraction. So we look, the numerator and denominator of each fraction look like they are completely factored. They're binomials this time, and there's nothing we can take out of each of these terms. So we're good. We can move on to step 2, where we state any excluded values. Those would be values of k in this case that would cause either of these denominators to equal 0. The good news is that each of these denominators are exactly the same. So we just take one of the denominators, set it equal to 0, solve for k. We get k is equal to -5. So that value of k would cause both of these denominators to equal 0. So our excluded value here would be k cannot equal -5. Now we can move on to step 3, where we make sure each fraction has a common denominator. Oh, They already do. So we can move on to step 4, where we multiply both sides by our common denominator to cancel it out. So we're going to multiply both sides of this equation by k plus 5. The reason is because over here, these k plus 5s cancel each other out, just leaving us with -2. On this side, the k plus 5s cancel each other out, just leaving us with k plus 3. Now I have this basic equation that I can solve for k. That's going to be our last step. So how do I solve this for k? Well, I need to get my variables to the left, constants to the right. So to get this k over here, all I have to do is either subtract k on both sides or flip my equation. Now I have my k on this side, so I just need to get my constants to the right. So this plus 3 has to go. I then subtract 3 on both sides to get rid of it. These cancel out, and I get k is equal to -5. Always at the end, check to make sure your answer is not included in your excluded values. Oh, it is this time. So what happens when your answer is your excluded value? Well, k cannot equal -5. Therefore, this cannot be one of your answers. So therefore, you have no answer, no solution. So you write no solution.
What's the coolest type of reptile? A blizzard! You try.
Okay, doing the same thing. First, we need to completely factor the numerator and denominator of each fraction. Since they're all monomials, we're good to go. We can move on to step 2, where we state any excluded values. So what values of a would cause either of these denominators to equal 0? Well, we set each of these denominators equal to 0, solve for a. Over here, we get a is equal to 0. That's one of our excluded values. Over here, we set this equal to 0, divide both sides by 2. We again get a is equal to 0. So our only excluded value would be a cannot equal 0. So we're going to move on to the next step, which is to make sure each fraction has a common denominator. So what is the least common denominator between 2a, a, and then since this is over 1, it would be 1. Well, I think it's going to be 2a. So how do I get this denominator here of 1 to be 2a? Well, I have to multiply it by 2a. And whatever I do to the denominator, I have to do to the numerator. Then plus. And then over here, how do I get this denominator to be 2a? I have to multiply it by 2. And whatever I do to the denominator, I have to do to the numerator. That way I'm multiplying by a form of 1 and not actually changing my fraction. And then equals. And then this denominator is already 2a. So I can just keep this fraction the same. Now when I multiply over here, I just get 2a over 2a. Then plus over here, 7 times 2 gives you 14 over our common denominator of 2a. And again, this fraction stays the same. Now, each fraction has a common denominator. So what we can do now is multiply both sides of the equation by that common denominator to cancel it out. Over here, I distribute the 2a to each of these fractions. This 2a cancels out with the 2a in the denominator here. And this 2a over here cancels out with this 2a in the denominator here, leaving us just with 2a plus 14 is equal to 14. Now we have this basic equation we can solve for a. So how do I solve this for a? Well, I get my variables to the left, constants need to go to the right. We start with anything added or subtracted to our variable. So how do I get rid of this plus 14? I subtract 14 from both sides. I get 2a is equal to 0. I then divide both sides by 2. I get a is equal to 0. That's my answer. Remember to make sure that your solution is not included in your excluded values. Oh, it is again. So what happens when your answer is in your excluded values? Well, a cannot equal 0, so this cannot be one of your answers. So we have no solution. So we write no solution. Okay, example 3, doing the same thing. We're solving this rational equation. The first step is to completely factor the numerator and denominator of each fraction. So we look over here, and it looks like the numerator and denominator of each fraction is completely factored. There's nothing we can take out of each of these terms or these terms, and these are just monomials. So we move on to the next step, where we state any excluded values. Those would be values of t that cause either of these denominators to equal 0. Well, over here, there isn't even a t, so there's no value of t that would cause this denominator to equal 0. But what about over here? To figure out what value of t causes this denominator equals 0. I just set it equal to 0, solve for t, add 4 to both sides. I get t is equal to 4. Therefore, when t equals 4, that causes this denominator to equal 0. So in this case, that's going to be our only excluded value. Now we can move on to step 3, where we make sure each fraction has a common denominator. So now we look, what is the least common denominator we can form between t minus 4 and 2? Well, in this case, I could just multiply this by 2 and this by t minus 4, and that would cause them to have the same denominator. So let's do that. I'm going to multiply this denominator by 2, and when I do, whatever I do to the denominator, I have to do to the numerator. So I'm multiplying it by 2 over 2, a form of 1, so it doesn't actually change our fraction. Then that's going to be equal to, and over here we said we have to multiply this by t minus 4, and whatever I do to the denominator, I have to do to the numerator. Now let's simplify these. Over here, 2, I'm going to distribute to the 4 and to the minus t in my numerator, and in my denominator, I'm just going to leave it factored out, 2 times the quantity t minus 4. We always do that just in case something cancels out at the end. Then we're going to put that equal to, and then we're going to distribute the t in my numerator to the t and to the minus 4. So it becomes t squared minus 4t. And again, in my denominator, I just leave it factored out. Now look, both fractions have a common denominator. So we can move on to the next step, which is to multiply both sides by the common denominator. So I'm going to multiply both sides of this equation by 2 times the quantity t minus 4. Why do I do that? Because it's going to cancel cancel out each of the denominators with these fractions, and we're just left with 8 minus 2t is equal to t squared minus 4t, an equation that we can now solve for t. So how do I solve this equation for t? Well, we have a t squared and a t term and a constant term. Anytime that happens, you need to get everything to one side of the equation and set it equal to 0. So I'm going to first add 2t to both sides of this equation. Now over here, the 2t's cancel each other out. On this side, negative 4t plus 2t is going to give you negative 2t. We then get the 8 to this side of the equation by subtracting 8 from both sides. And note that these cancel each other out, but over here, this has a t, this does not. So we cannot subtract these two things. So what we're going to have to do then is just tack on a negative 8 at the end of this polynomial. So now we have a quadratic trinomial. How do I solve a quadratic trinomial? I use the magic x. So I take my a value, which is 1, multiply it by my c value, which is negative 8, put that in the top of the magic x. I take my b value, which is negative 2, put that in the bottom of the magic x. I think about two numbers that multiply together to make negative 8 and add together to make negative 2. That's going to be negative 4 and positive 2. I then divide each of those by my a value, which we said was positive 1, and we're going to write our factored form in two sets of parentheses, going bottoms up. In the first set of parentheses, it's going to be 1t minus 4. In the second set of parentheses, it's going to be 1t plus 2. Now I have two things multiplied together that equal 0, so I can use the zero product property to solve this. I'm going to set each of these factors equal to 0 and solve for t separately. Over here, I add 4 to both sides to get t by itself, and I get t is equal to 4. On this side, I subtract 2 from both sides, and I get t is equal to negative 2. So I have two solutions to this problem. Now, I need to make sure that neither of these solutions are included in my excluded value. So I look at the beginning of the problem, and I see that t cannot equal 4. Oh, that is one of my solutions. So this cannot be a solution to our problem. So we only have one solution. T is equal to negative 2.
What do you call an underwater reptile who solves crimes? An investigator! You try.
Okay, doing the same thing here. So step 1, we want to completely factor the numerator and denominator of each fraction. So it looks like we are completely factored and ready to go. We could make this 2 times 2 times 2, but we're just going to leave it as 8 for right now. So we move on to step 2, where we state any excluded values. What values of x would cause any denominator in this equation to equal 0? Well, we'll start with this denominator. We set this equal to 0, solve for x, we get x is equal to negative 3. So that's going to be one of our excluded values. Then over here, we set this denominator equal to 0, solve for x. We just get x is equal to 0. So we have two excluded values. X cannot equal negative 3 or 0. So we can move on to the next step, where we make sure each fraction has a common denominator. So we need to figure out what is the least common denominator between x plus 3, x, and then since 1 we write as a fraction 1 over 1, it would be 1. So our least common denominator between x plus 3, x, and 1 would probably just be x times x plus 3. So what do I have to do to this denominator to make it x times x plus 3? Just multiply it by x, and whatever I do to the denominator, I have to do to the numerator. Then I'm going to have equals, and then over here, what do I have to multiply this denominator by to get it to be x times x plus 3? Well, that would be x plus 3, and whatever I do to the denominator, I have to do to the numerator. And now, how do I get 1 over 1, because that's what 1 is, to have a denominator of x times x plus 3? I multiply it by x times x plus 3, and whatever I do to the denominator, I have to do to the numerator. Now I can simplify each of these. Over here, in my numerator, 8 times x is going to give us 8x, and in my denominator, again, just leave it x times the quantity x plus 3, because hopefully something will cancel out later on. Then we write equals, and then 1 times x plus 3 is just going to give us x plus 3 in the numerator, and then in my denominator, again, leaving it x times the quantity x plus 3. Then plus, and then over here, 1 times x plus 3 is just going to be x times x plus 3 over x times x plus 3. Now what I can do, since each fraction has a common denominator, they have the same denominator, I can move on to step 4, where I multiply both sides of the equation by that common denominator. So I'm going to multiply both sides of this equation by x times the quantity x plus 3. Now why do I do that? Because over here, these are going to cancel each other out, getting rid of our denominator. Over here, I distribute the x times the quantity x plus 3 to each fraction, and it again cancels out each denominator, leaving us with this basic equation that we can now solve for x. That's step 5. So how do I solve this? Well, I need to simplify first. I distribute the x to the x and to the 3. I then combine like terms. X plus 3x is just going to give us 4x, and then this plus 3 I just move to the end. Now look, I have an x squared term, an x term, and a constant term. So I need to get this 8x over here, so I could set this equation equal to 0. So I'm going to subtract 8x from both sides. 4x minus 8x is going to give us negative 4x. And now I have a quadratic trinomial set equal to 0. How do I solve that? I use a magic x. So first, I make sure that I can't factor out anything from each of these. Nope, these are good to go. So we take our a value, which is 1, multiply it by our c value, which is 3, put that in the top of the magic x. We take our b value, which is negative 4, put that in the bottom of the magic x. Think about two numbers that multiply together to make positive 3, add together to make negative 4. That would be negative 3 and negative 1. We then divide each of those by our a value, and we write our factored form in two sets of parentheses, going bottoms up. In the first set of parentheses, it's going to be 1x minus 3. In the second set of parentheses, it's going to be 1x minus 1. We then have two things multiplied together that equal 0, so we can use a zero product property to solve this. We're going to set each of these factors equal to 0 and solve for x. So over here, we add 3 to both sides. We get x is equal to 3. Over here, we add 1 to both sides. We get x is equal to 1. So we have found our two solutions to this equation up here. But we need to make sure that neither of these are included in our excluded values. They are not, so we have our answers. Example 4, doing the same thing. So step 1, we need to completely factor the numerator and denominator of each fraction here. So our numerator here is just 1. That's good to go. 3s plus 2, is there anything we can factor out of those? No. So our first fraction is completely factored. Our next fraction, we have 4 in our numerator. You could write that as 2 times 2, but we're just going to leave it as 4 for right now. In our denominator, we have 2s minus 4. Is there anything we can factor out of each of those? Yeah, a 2. So I'm going to write a 2 on the outside of a set of parentheses, and on the inside, I just divide each term by 2. Then that's going to be equal to, over here, 5s. That's as factored as that gets. But in our denominator, we have a quadratic trinomial. So we can factor this using a magic x. But before we use that, is there any greatest common factor we can take out beforehand? No. So we go straight to the magic x, where we take our a value 3, multiply that by our c value, negative 4, put that in the top of the magic x. We take our b value, negative 4, put that in the bottom of the magic x. We think about two numbers that multiply together, make negative 12, add together, make negative 4. That's going to be negative 6 and positive 2. We then divide each of those by our a value, which we said was positive 3, and then simplify each of these fractions if possible. We weren't simplifying before because our a value was 1, but here it's 3. Can we simplify this? Yes, it becomes negative 2. But instead of writing negative 2, we write negative 2 over 1. We want to keep it as a fraction. Over here, 2 over 3, that's as simplified as it gets. So now we can write our factored form as two sets of parentheses going bottoms up. We start with this over here. We go 1s minus 2 in the first set of parentheses. In the second set of parentheses, it's going to be 3s plus 2. Now we have completely factored the numerator and denominator of each fraction, so we can move on to the second step, which is to state any excluded values. So what values of s would cause any of these denominators to equal 0? So we set this denominator equal to 0, solve for s. So when we do that, we subtract 2 on both sides, divide both sides by 3. We get s is equal to negative 2 over 3. That's one of our excluded values. Here, we set this denominator equal to 0, solve for s. We divide both sides by 2, add 2 to both sides. We get s is equal to 2. That's one of our excluded values. And then here, we set this denominator equal to 0, solve for s. So we need to use the zero product property because we have two things multiplied together equal 0. So we set each of these things equal to 0, solve for s. Oh, they're the exact same things we got over here. S cannot equal 2 and s cannot equal negative 2 over 3. So those are our only two excluded values. Now we move on to step 3, where we make sure each fraction has a common denominator. So we need to determine what is the least common denominator between 3s plus 2, 2 times the quantity s minus 2, and then s minus 2 times 3s plus 2. Well, it looks like our least common denominator is going to have to be 2 times the quantity s minus 2 times 3s plus 2. Now, you may think, how in the world did you figure that out? Well, it just takes a lot of practice. You do a bunch of these, you'll start seeing what the least common denominator has to be. So in order to get this denominator to be our least common denominator, 2 times the quantity s minus 2 times 3s plus 2, I need to multiply this denominator by 2 times s minus 2. And whatever I do to the denominator, I have to do to the numerator. Then I'm going to add that 2 over here. How do I get this denominator to be our least common denominator? Well, I just have to multiply it by the quantity 3s plus 2. And whatever I do to the denominator, I have to do to the numerator. And then that's going to be equal to, and then over here, I have to get this denominator to be 2 times the quantity s minus 2 times 3s plus 2. So what do I have to multiply this by? That would just be 2. And whatever I do to the denominator, I have to do to the numerator. Now, I just simplify each of these. Over here, 1 times 2 times the quantity s minus 2 is just 2 times the quantity s minus 2. And in my denominator, remember, I'm just going to leave it fully factored out, just in case something cancels out at the end. Then I'm going to add that 2, and then I have 4 times the quantity 3s plus 2. I actually have to distribute that 4 to the 3s and to the 2. So it's going to be 12s plus 8. And then in my denominator, just leave it fully factored out. Then that's going to be equal to, and then I multiply 5s times 2 in my numerator, that's just 10s, and then leave my denominator fully factored out. Now, as you can see, each fraction has the exact same denominator. We have a common denominator. So we can move on to step 4, where we multiply both sides of the equation by that common denominator. So when we do that, over here, we're going to distribute our common denominator to each fraction. And what happens is it cancels out each denominator. Over here, we multiply these two together, and the denominator cancels out, and we're just left with this basic equation that we can now solve for s. That's step 5. So let's simplify first. I distribute the 2 to the s and to the negative 2. I then combine like terms. 2s plus 12s is going to give us 14s, and then negative 4 plus 8 is positive 4. I then solve this by getting all the variables to one side, all the constants to the other side. So I'm going to subtract 10s from both sides, then subtract 4 on both sides, divide both sides by 4. I get s is equal to negative 1. That is my solution to this equation up here. Remember to check to make sure that this is not included in your excluded values, which it is not.
My favorite Ninja Turtle is Donatello, but this is the only outfit I can find. You try.
Okay, doing the same thing here. So we start with step 1. We need to completely factor the numerator and denominator of each fraction. So it looks like we're good to go here, actually. So we can move on to step 2, where we state any excluded values. What values of c would cause either denominator to equal 0 here? Well, we set c minus 2 equal to 0, solve for c. We get c is equal to 2. That's one of our excluded values. Over here, we set this denominator equal to 0, solve for c. We just get c equals 0. So our two excluded values are going to be c cannot equal 2 or 0. So now we move on to step 3, where we make sure each fraction has a common denominator. So what is the least common denominator between c minus 2? Since this is just 2, it's going to be 2 over 1. So 1 is our denominator here. And then c. Well, it looks like it's just going to be c times the quantity c minus 2. So how do I get this denominator to be c times the quantity c minus 2? I just multiply it by c. And whatever I do to the denominator, I have to do to the numerator. Then it's going to be minus. And then remember, 2 is the same as 2 over 1. So what do I have to multiply 1 by to get it to be c times the quantity c minus 2? That's c times the quantity c minus 2. And whatever you do to the denominator, you have to do to the numerator. Then that's going to be equal to. And now over here, what do I have to multiply c by to get it to be c times the quantity c minus 2? That would be c minus 2. And whatever I multiply to the denominator, have to multiply to the numerator. Now what I do is I simplify. Here, 2 times c is going to give us 2c. In my denominator, I just have c times the quantity c minus 2. Remember to leave that factored out. Then that's going to be minus. And up here, 2 times c times the quantity c minus 2 is just 2c times the quantity c minus 2. And in my denominator, just leave it factored out. And then that's going to be equal to, up here, this negative 4, I can distribute to the c and to the negative 2. That's going to be negative 4c plus 8. And that's all over our common denominator. Now, each fraction has the exact same denominator. We have a common denominator. So we can move on to step 4, where we multiply both sides of the equation by that common denominator to cancel it out. Here, we distribute c times the quantity c minus 2 to each of these fractions. And when we do, it cancels out both denominators. Over here, when you multiply this by this fraction, the denominator also cancels out, just leaving us with this basic equation that we can now solve for c in step 5. So how do I solve this for c? Well, first, let's simplify. Here, I'm going to distribute this negative 2c to our c and to the negative 2, and I end up getting this right here. Now I can combine like terms. 2c plus 4c is going to give us 6c over here. And notice we have a c squared term, a c term, and a constant. So we need to get everything to one side of the equation. Doesn't matter whether it's this side or this side. I'm going to actually move everything to this side of the equation over here. So I'm going to subtract 6c from both sides. These are going to cancel each other out. And on this side, negative 4c minus 6c is going to make it more negative. It's going to be negative 10c. I then get this negative 2c squared to this side by adding 2c squared to both sides. And now these cancel each other out. Over here, this is c squared, this is c. So we can't actually add these together. We just put this in the front. And now we have a quadratic trinomial set equal to 0. When that happens, how do I solve this? Use a magic X. But before you use a magic X, always check, is there a greatest common factor we can take out of each term? Yeah, actually, there's a 2 we can take out of each of these terms. So I'm going to take a 2, put it on the outside of a set of parentheses, and on the inside, I divide each of these terms by 2. Now that we factored out our GCF, we can use the magic X to factor this quadratic trinomial right here. We take our a value, which is now 1, and multiply it by our c value, which is now 4, and put that in the top of the magic X. We take our b value, which is now negative 5, put that in the bottom of the magic X. We think about two numbers that multiply together to make positive 4, add together to make negative 5. That's going to be negative 4 and negative 1. We then divide each of those by our a value, which we said was positive 1 now, and we write our factored form as two sets of parentheses going bottoms up. In the first set of parentheses, it's going to be 1c minus minus 4. In the second set of parentheses, it's going to be 1c minus 1. We then have three things multiplied together that equal 0. So we got to use the zero product property. You could just divide both sides by 2 right away and get rid of this 2. So it's really just these two factors we're focusing on. We need to figure out what values of c would cause either of those factors to equal 0. So when we set those equal to 0, solve for c. Over here, we add 4 to both sides, we get c is equal to 4. Over here, we add 1 to both sides, we get c is equal to 1. Now we have two solutions to this equation up here. Please check to make sure that neither of these are included in your excluded values. They are not, so we are good. We're done.